Hello everyone, myself Sai Prasad, a lecturer in Ahmedabad High School and the Junior College. Welcome to the series of the lectures of 8th class maths. We have started a discussion with squares and square roots and cube roots. This is a chapter we have started. What did we learn? We learned what are squares, what are square roots, and we learned different kinds of concepts, how do we find squares, square roots and everything. Today we will learn what are cubes and cube roots, right? What did we learn in the last chapter? We learned the square roots, how do we find using factorization method and the division method. Okay, today let us do a few more problems of that. See here, the question given here it is, he is asking us to find the least number which must be added to 6412 to make it as a perfect square. Okay, how do? We will do by using prime factorization method, or else let us do by using division method. Okay, see here, what is it? 6412. Tell me, how do we do? 6412. Okay, 64 is a square of 8 8s, that is 8 8s 64 we directly get. Okay, after this double of 8 is, what do we get? That is 16. Here we have to bring 12 here, there is nothing we can't do. Okay, now tell me what is the number left, which means the least number which is to be added to this is 12, that is 6412. If I add some number, I may get some other number. Okay, now what do we do? In which table this will go? 160 zeros are again 0 0, after subtracting I will get it as 12. Okay, which means it is 160 into 80 point something, which means obviously it lies between 80 and 81 square. This is the number lying between 6412. Okay, now tell me what is 80 square? 8 square is 64, 00 less than 6412 less than 81 square. Let us multiply 1 8 64. Again, how much is it? Again here also 8 ones are 8, 8 8s are 64. That is 1 16 5 6. This is 6561. Okay, now tell me what is the difference between these two? That is 6561 minus 6412. That is, how much is it? 149. This is the 149 is the least number added to 6412 to make perfect square. Okay, is it clear? That is what he is asking us. Look at this next question. He is asking us to estimate the value of root 97 root 780. Okay, now tell me, 97 lies between which two perfect squares? 97 lies between two perfect squares. What are those? 81 and 100. That is 81 and 100. Okay, if you tell me the square root of 81, square root of 97, square root of 100 is 9 less than root 97 less than 10. What does it mean? It lies between number 9 and 10. 97 is near to 100, therefore square root of 97 is almost 10. Okay, you have to check whether this number is nearest to before square root or after square root. Yes, it is near to 100, that's why I have written square root 97 is almost 10. Is it fine? Good. See here, the next question, that is root 780. Tell me, 780 lies between which two perfect squares? Tell me, those are 729 and 784. How? 27 square is 729, 28 square is 784, which means square root of this, square root of this, square root of this, that is 27 less than 780 less than 28, which means this lies between 27 and 28, where here 28, this means the 780 is very near to 784, therefore root 780 is almost all equal to 28. Is it clear? Is it right? Did you understand? Fine. Shall we learn what are cubes and cube roots now? Let's do. Now tell me, what are cubes? What do you know about cubes? As we have learned, if square is, for example, if I tell a square, that is a power 2, that is nothing but a into a. Okay. Cube means a power 3. This power is called as cube. That is, if it is 3, we tell it as cube. That can be written as a into a into a. Is it right? Can you understand this? If I tell 1 cube, that is 1 into 1, that is, however, it is again 1. If it is 2 cube, 2 into 2, that is 2 2s are 4, 4 2s are 8. And the next 3 cube, 3 into 3, 3 3s are 9, 9 3s are 27. Yes. Then 4 cube, 4 into 4, that is 64. 4 4s are 16, 16 4s are 64. Similarly, 5 cube is 5 into 5, that is, how much is it? 125. 5 5s are 25, 25 5s are 125. Right? Similarly, 6 cube, 7 cube, 8 cube, 9 cube, 10 cube. 10 cube is again 1000. Right? Can you write all this? Can you remember? Which means, as you have seen in the squares, here also will have fixed unit numbers. I mean unit place numbers. Okay? If you observe, in the unit place, if you have 0, 4, 5, 6 and 9. Right? In order to check whether a given number is a perfect cube or not, you have to check whether you have these numbers in unit place or not. Okay, the first condition is you have to check whether the unit place have these numbers or not, at least. Okay, if it is yes, then you can go on to how do you find cube, rectangle and everything. Is it clear? Did you understand? Yes? Very good. Now tell me, can you find out how to check whether a given number is a perfect cube or not? Tell me. Tell for this number 243. Is it a perfect cube? Obviously no. Why? Because there is no 3 here. Therefore, it is not a perfect cube. Okay. 729. Tell me, is it a perfect cube? Yes, it is a perfect cube. That is the cube of this 7. Okay. That is, it is a perfect cube. Now tell me, is it a perfect cube? 00, which means we have 0 here. Yes, there is a chance of perfect cube, but 27 is a cube, but not 00 is a cube. Therefore, it is not a perfect cube. But if it is 0, we can tell. Fine? Very good. Can you find the cubes? This is checking whether it is a perfect cube or not. Can you find the cube of any number? That is just multiplying. Okay, is it clear? Did you understand? Now see here, you have to remember all this. Let us find cube of 8. 8 cube is 8 into 8 into 8. 8 8s are 64. 64 into 8. How much is it? 8 4s are 32. 8 6 are 48. 51. Okay. 68 cube is 512. Is it clear? Did you understand? Shall we move on to the next problem? Let's do. Now see here. The question given here it is, he is asking us to find the smallest number by which this must be multiplied to get a perfect cube. How do we do? We already know, to check whether a given number is perfect cube or perfect square, we have to do prime factorization. Let us do that. 8 7 8. Let us divide it with 2. Okay. 2 4s are 8. 2 3s are 6. Again 2 9s are 18, 2 4s are 8, again 2, 2 2s are 4, 2 1s are 2, 2 9s are 18, 2 7s are 14. Now tell me 2197, in which table does it go? 7, 8, 10, 19. Which table? 2197. Tell me. That goes in 13 table, 13 into 169. 169 is 13 13s are. Okay. Now tell me, now what can I write? 8788 as 2 into 2 into 13 into 13 into 13. There are 3 13s. Yes, it's okay. Then what about these 2's? In order to get as a perfect score, I have to multiply perfect cube. I have to multiply one more 2. That is, in order to make 8788 as perfect cube, we have to multiply 2. Okay, is it clear? Do you understand? See here. Now one more question. This is again a very easy and important. Ravi made cuboid of dimensions 12, 8 and 3. Length is 12, height is 8 and breadth is 3. He is asking how many minimum number of such cuboids will be needed. Okay. What is the volume of a cuboid? L into B into H. That is, we have to multiply all those 3. Okay. That is cuboid volume is equal to 12 into 8 into 3. Okay. Now factorize it. Okay. And check whether you will get a perfect cube or not, because the volume of a cube is a cube. Okay. See here, 12 can be written as 2 into 2 into 3. Okay. 8 can be written as 2 into 2 into 2. Then next 3. Is it fine? Now if you observe here, in order to find that, I have to check this. For 3 2's, I have to write 1 cube, or else let us write it in a simple way. This is 2 cube into 2 square into 3 square. Right? What is that I have to multiply more? 2 is okay. Then I have to multiply 1 more 2 and 1 more 3. That is 2 into 3. Therefore, how many minimum number of such cuboids will be needed to form a cube? Okay. How many number of cuboids will be needed to form a cube? How many do we need? That is, we need how many? 6 times of cuboid. That is, we need 6 number of cuboid to form a cube. Is it clear? Is it easy to understand? Shall we do next problem? Let's do. See here, the next question, that is, he is asking us to find the cube root of these two numbers. Right? How do we find? Let us do by prime factorization. Is it fine? See here, 729. How do we do? That is, let us take which table? Here it is 2, and 7 plus 2 is again 3. It goes in 3 table. 3 2s are 6. Again 3 4s are 12, and the next 3 3s are 9. Again 3 8s are 3 1s are 3 into 27, 3 into 9, 3 3s are and 3 1s are. Okay, that is 729 can be written as 3 into 3 into 3 into 3 into 3 into 3. 1 2 3 4 5 6 3 3. Therefore, cube root of 729 is 3 into 3, that is 9. Is it clear? Similarly, let us find 2744. In which table does it go? Obviously 2 table. 2 1s are 2, 2 3s are 6, 2 7s are 14 and 2 2s are 4. 1 3 7 2, again 2 table. 2 6 are 12, again 2 8s are 16, and the next 2 6 are 12. Again one more. 2 3s are, 2 4s are, 2 3s are. Again 343. In which table does it go? 3 plus 3, 6 6 plus 4 10. No, right? It goes in 7 table. 7, what's that? 7 4s are 28 and 7 9s are 63. 7 7s are again 7 1s are. Okay. Now tell me, square root of 2744 is square root of 2 into 2 into 2 into 7 into 7 into 7. 3 7s, 2 2s, that is 2 into 7, that is 14. Is it clear? You do understand? Fine, this is what you have to remember. Now what about 2197? Whose cube root is this? 2197 should lie between any two cube roots. Perfect cube root. What are those? Tell me. Tell. If you observe here, 7 is a number. In which table do we get 7? That is only in 3. Which means either it should be 3 or else it should be 13. Right? How can we expect 1000 cube is? Tell me, 10 cube is 1000. After that, I have to get 2917, that is nothing but my 13 cube. Okay. What about 3375? Tell me, this is also 5. When do we get 5? After this number, obviously 15. Right? This is just expectation. It doesn't mean that should be fixed. If you want to do, you can try. Is it clear? Now tell me, what did we learn? We learned what are squares, square roots, cubes, cube roots and everything. Can you tell me a number which is both a square and a cube? A 2-digit number. Tell me. That is, just check. 2 square, 3 square, 4 square, 5 square, 6 square, 7 square, like that. Tell. Which is it? That is 64. 64 is a square of how much? 8 square, and it is also cube of 4. Isn't it? This we know this, right? Fine. These are all different questions they will ask from this chapter. Is it clear? Fine. By this problem we have ended this chapter, that is square roots and cube roots. Is it okay? Good. Let us meet in the next session with the more problems of